Hello and welcome. In this video, we're going to run a log-log regression and then interpret the regression coefficient estimate results from our log-log regression. So yeah, let's suppose that we start off with the following model. And in this model, the independent or explanatory variables, education, experience, and age, are all in log terms. And our response variable, wage, the dependent variable, is in log terms as well. So let's say we have this model. Let's say we collect some data and we run a few regressions, and we come up with the following. These results you might get from something like R software, R statistics software. You might get regression results that look something like this. So for our estimate of beta naught, we have the intercept here, 1.5. For our intercept of beta 1, we have the education coefficient here, 3.3. It actually looks something like this. These I just created and made up myself, so don't really get any true intuition from them, but they're not unreasonable. So let's say that our estimate for the beta 1 coefficient is the following, 3.3. Estimate for beta 2 is 1.2, and our estimate for beta 3 is this 0.4. How do we interpret that? If we had a change in education, what can we expect a change in education to have an effect on wages? Well, before we could interpret our results, we need to get a few kind of assumptions out of the way. The first assumption is the Gauss-Markov assumptions. The Gauss-Markov assumptions need to hold in order for us to correctly interpret these regression coefficient estimates. So second off, we need our regression coefficient estimates to be statistically significant. So the way I arbitrarily wrote these, the t-values are sufficiently large and the p-values are sufficiently small that they're statistically significant. They also need to be practically significant. Practically significant is a qualitative kind of thing, but it's in the sense that the results here can't be minuscule. They have to have like a noticeable effect. And then lastly, when we interpret the say beta 1 here, the effect of education on wages, we are going to need to hold our other variables, education, experience, and age. We need to hold the other variables in our multivariable regression. We need to hold them constant. So if we can agree to these assumptions, we could then get to interpreting beta 1. So to correctly interpret our beta 1 coefficient, the first thing we're going to do is take the differential of our model with respect to education. So that's what I'm setting up here. What happens when we take that first derivative with respect to education? Well, since we have log wage here, remember, like if you have a log of x, the differential of log x is dx over x. So when we take the first derivative of log wages here, we have the change in wage divided by wages. Similarly, over here, when we do it to beta 1 times log education, we get de-education over education times beta 1. One thing to notice about this, so d-wage is just kind of like the change in wage. We're curious how this change in education is going to affect the change in wage. So something interesting, that d-wage right here is the change in wage, and the wage here is the base level of wages. So d-wage over wage, that is the change in wages in percent. So what's interesting about this is if you take this times 100, that's going to give you the percent change in wages. So the percent change in wages is a useful statistic that we could use to interpret our results. So the next step here, we're going to times both sides by 100, so that we have 100 times d-wage over wage, and we have 100 times the change in education divided by education. So reinterpreting what those are, so 100 times d-wage over wage, that is equivalent to the percent change in wages. So reinterpreting this result, we now have the percent change in wages is equal to the percent change in education times our beta 1 coefficient. Okay, so we did a little math, but what exactly does that mean? How do we interpret the value of beta 1 that we got here? How do we interpret this 3.3? So what this tells us is that if we increase education by 1%, we can expect wages to increase by beta 1%. Since beta 1 is 3.3, if we increase education by 1%, then we expect wages to increase by 3.3%. Simple as that. So this beta 1 term here is the partial elasticity. A way to interpret it is it's the percent change in wages given a percent change in education, holding everything else constant. Cool, so hopefully that was helpful. If it was, be sure to give the video a thumbs up. And let me know if you have any questions, and thanks and have a good day. Bye.